Hello everyone. So I'm going to explain the lab program that is bubble sort. Okay. So I'll first read out the program statement. So we are given some numbers and we have to sort those numbers using bubble sort. So the program statement is sort the given set of n numbers using bubble sort. Okay, so here is the explanation for how it works. So first of all, what is bubble sort? Bubble sort is a simple sorting algorithm that works by repeatedly swapping the adjacent elements if they are in the wrong order. Okay, so usually bubble sort can be done for greater to smaller or from bigger to you know smaller to bigger. Okay, so you can arrange the numbers either in ascending order or you can do it in the descending order also. Okay, I have given the working, you can go through it here. Now I'll take an example and show you how bubble sort works. See here, we have to carry out the bubble sort on the following numbers. These are the numbers 15, 6, 6, 8 and 5. The idea for the bubble sort is take the two numbers at a time and check if they are in an order or not. For example, if I want to arrange these numbers in ascending order, okay, see, I want to arrange numbers in ascending order. So what happens is I will first take these two numbers. You will have to take the numbers in the adjacent position. So 15 and 16. Okay, I am arranging it in ascending order. So I will compare these two numbers 15 and 16. I see that the numbers are already in the order because 15 is smaller and it is in the left position. So you don't need to do anything. You don't need to exchange. You'll keep it as it is. See, first time. Okay. So you have the numbers like this 15, 16, 6, 8 and 5. You will check these two numbers 15 and 16. You will see that the numbers are already in the order. So you don't need to change. You'll keep it as it is. After you're done with 15 and 16, now you will go to the next two position, 16 and 6. It's like 0 and 1, 1 and 2, 2 and 3, 3 and 4. Okay. Now I will check for the next position. See, 1 second. Okay. See, it will check for 16 and 6. You will see that 6 is actually smaller than 16. So what happens is the numbers will get exchanged. Okay. Now you will compare the next two positions. So 0 and 1 is compared, 1 and 2 is compared. Now 2 and 3. You will again see that the number needs to be exchanged because the smaller number is on the right side. So we'll exchange. We'll continue this till the end. Now I have checked 0 and 1, 1 and 2, 2 and 3, 3 and 4. So once I have checked all the elements, okay, but if you see, though I have checked all the elements, the numbers are not in the order. See, 5 has to come to the first position, okay. So what are we supposed to do? We are supposed to do the comparison all over again. So whatever we have done here has to be repeated again, okay. And one more thing, see, by the end of the first comparison, you will see that the element in the last position is the sorted element. See, 16 is supposed to be the biggest number that was supposed to be placed on the rightmost side. And as you can see, 16 is in the rightmost side. Now we do the same comparison. See here, we have the numbers. Okay, we do the comparison. Okay, so 0 and 1, 1 and 2, 2 and 3, 3 and 4, and you see that the elements look like this after the end of the comparison. And if you see, the elements are again not in the order. 5 should be in the first position. So we do this thing all over again. So we do the same thing all over again. Okay. So we'll be doing this. See, by the end of the fourth pass, if I'm doing the comparison of the element 4 number of times, you can see that the elements are in the sorted order. You can see here 5, 6, 8, 15 and 16. Okay. Now you see this. How many total number of elements are present? So 15 is there, 16, 6, 8 and 5. Okay. These are the number of elements. So we have total of 5 elements. And see the number of times we have compared. So if there is 5 number of elements, the number of comparison is 4. So if I have 10 elements, the number of comparison is 9. So if I have n elements, the number of comparison would be n minus 1. Okay. I hope you have got it. So if you have n elements, the number of comparisons should be n minus 1. See here. 5 elements and the number of comparisons are 1, 2, 3 and 4. This is one thing. Now you see here. There should be 2 loops in this program. I hope you understand why 2 loops. One loop is for the comparison itself. So it should be for I equal to 0, I less than, because there are n elements, the number of comparison is n minus 1. So I equal to 0, I less than n minus 1, I plus plus. Okay. The other comparison is when you compare the adjacent elements. So it can be something like, for I equal to 0, I less than n minus 1, because see here, 1 comparison, 2 comparison, 3 and 4. So again, internal comparisons are also n minus 1. See here, 1, 2, 3 and 4. So you should have 2 loops. One is for the main comparison, one is for this internal comparison. Okay. So that also, if you think for I equal to 0, I less than n minus 1, I plus plus. But one more problem here is, or you can optimize this program. See here, what you can do is, our ultimate goal for designing an algorithm is reducing the number of steps in the program. Okay, and to also make sure that the program executes without errors and the efficiency is also more. That means the number of steps should be less. It should perform the designated task and it should also give you the proper output. Now you see here. Okay, see here. First pass, we are doing 4 comparisons. Okay, but you see in the second pass. See the second pass very carefully. This is the first comparison. This is the second comparison. 3 and 4. Okay. If you see the fourth comparison here, fourth comparison, do you really need this comparison? Do you really need this comparison? You don't really need this because the elements are already sorted over here. Come to the next part. Okay. So for example, if, wait. So we don't really need this step. But when you come here also, you see this. This step not required. What about this step? Do we really need this step? We don't really need this step because after the second comparison itself, the numbers are sorted. And come here to the fourth pass and check this comparison. From this comparison itself, okay, the numbers are in the sorted order. So you don't need to compare this, this and this. These 3 steps can be avoided. Here 1 step, here 2 steps and here 3 steps. Okay. Here when you initially do the first comparison, I will be equal to 0. Then I will be equal to 1. I will be equal to 2 and then I will be equal to 3. So the internal comparisons can be, see how the optimization will happen. For I equal to 0, I less than n minus 1 minus I. At that time, whatever I value is there, that many number of steps can be reduced. So here I will be 3, okay, in the last comparison, and 3 steps can be avoided. So internal comparison is, well, let's start with the outer one. Outer one is anyways for I equal to 0, I less than n minus 1 and I plus plus. For the internal comparison it is for I equal to 0, I less than n minus 1 minus I plus plus. This is how you're going to compare. And I hope you know how to compare the two adjacent elements with respect to an array. So if this is A of I, this is the next higher position. So A of I plus 1. So you will compare something like if A of I is greater than A of I plus 1, I hope you know you have to insert a temporary variable and do the swapping. Okay, this is how it is going to work. Okay, so I will open the program and show it to you. Let me open the program. See here. So we have a program like this. This is the program statement. So you have to develop using bubble sort. So I hope first part you understand. So first line is the header file, then the main function. So we have these elements here. So I is for the loop, n is for the total number of elements, a of 10 is the array itself, j is for the, there should be two loops, right? So one I'm using for the outer, this is for the internal comparison, and we need a temporary variable to do the swapping. The first thing that you will do is ask the size of the array. You will do that. After that, once you have the size of the array, you will ask the user to input the elements into the array. Okay, so for I equal to 0, I less than n, I plus plus, scanf, percentage d, array of I. So you'll be able to input. Once you have done that, whatever elements you have input, that you are supposed to display. That is happening from here to here. Whatever you have input in this part will be displayed over here. So for I equal to 0, I less than n, I plus plus, printf percentage d, a of I. Now the comparison. I hope you remember there are two loops I said. One loop is for the total comparison. It will be 1 less than the total number of elements. And this is for the internal comparison. So if you have elements like these, then comparing these two elements. So n minus 1, n minus 1 minus I. And how do you do the comparison? By checking the element in the first position with the second position, for example. I mean two adjacent position. So if a of j is greater than a of j plus 1, then you insert the temporary variable and do the swapping. You remember this, I hope. So there will be temp, there will be a of j and a of j plus 1. Let's say this is 15 and this is 5. First what you do is, you take the element at a of j and place it at temp. So this becomes empty, a of j plus 1 is 5. Then what you do is, take the element at a of j plus 1 and place it here. 15 is already there in temp, this becomes empty. Now you see, a of j plus 1 element has come to a of j. Now what you are supposed to do is, move this here. So 5 and then 15. So a of j plus 1 would be getting the element 10. Once you're done with that, whatever you have sorted should be displayed. Okay, so this is the bubble sort program. So you'll have, for example, if you have given the size 6 and you have given these elements 31, 40, minus 40, 100, 20 and 1. First thing, it will display the elements as it is before sorting, and then it will display the elements after sorting. Okay, so I hope you understand. Bubble sort is comparing the two adjacent elements, and based on the order that we want to sort, we will swap the numbers. Okay, and then we do this repeatedly till all the numbers are sorted. Thank you. I hope you have understood.